Well, hi, thanks for joining me here in my shop. What I'm hoping to do next, I gotta use the word hope these days, is to do the shortwave front end alignment on this radio, see if we can't pick up its performance. But the first thing I want to do is take a look at the capacitors I took out of it. I'm going to check them out here and see just how good or bad they were. So I think there's 5 of them here now. I'll run through them here. Marconi. Now, just in case you haven't seen me use this device before, this machine will put a high DC voltage on a capacitor and then measure in a very sensitive way how much current is leaking through the capacitor. We're talking about tiny, tiny amounts of current. And it's reflected on this magic eye, which is maybe a little hard to see. Let me just turn this over here. See it opening? Yeah, you can see that in the camera. Okay, so you saw it closed and you saw it open. So with the test I'm about to do, I've got this set to 25 volts. And when I turn this knob over to leakage, it's going to apply the 25 volts on the capacitor, and this eye is going to respond. First, it's going to close suddenly while current rushes into the capacitor. Assumably, current is rushing into the capacitor. It is a small amount, but still, it takes a tiny amount to close this eye. The eye's going to close and then pop open again. If the capacitor is good, this will happen very quickly. A small capacitor, pop open quickly and look just like this. And that tells me there's no or very negligible amount of leakage current, and the capacitor is a thumbs up. On the other hand, if the capacitor is leaking any appreciable amount of current, this eye will be half closed or totally closed. Okay, let me just shuffle things around a little bit here. There we are. Okay, first capacitor, 25 volts. A little hard to see in the camera now, isn't it? Look at that. Just change the lighting a little bit. Whoop. Let's try that. Okay, so we'll do this again. 25 volts. Close and opens about 3/4 of the way. So I can guess at 150 volts it won't open at all. And I can easily declare this capacitor a leaky capacitor. Now in some places in the radio it really wouldn't matter. A tiny amount of leakage just doesn't really matter that much. It may matter on a technical level, but on a performance level it may not matter all that much. On the other hand, in other locations, a leaky capacitor like that will cost you a vacuum tube. Okay, 25 volts on the big guy. Okay, see that pop open so quickly there? I don't think this is working at all. So I may have a bad connection here, because I expect that eye to close and come open slowly on a capacitor of this size, 0.1. Let's try again. No? Well, that's kind of interesting. Let's take it up. Okay, if it keeps doing this as we go up in voltage, that suggests to me that there's an open circuit inside the capacitor itself. Because there's no way at 250 volts and a 0.1 capacitor charges up instantly. There's just no way. So this guy is really quite shot. And literally the wire lead may have separated from the foil inside here. Just open circuit. Next one. Sealed tight. $25 volts on the sealed tight. That was pretty good. Came right open. Excuse me. That's pretty good. 250 volts. So this capacitor is actually working quite well. So it's working well enough we can try measuring its value. If it was leaking, seriously, we wouldn't be able to. So I'm just going to give it a moment to discharge here. When this switch is sitting on the normal position, there's a short in here. discharges the capacitor. So, okay, let's go measure it. See, now this time, as I turn this knob, you watch for the eye to pop open. Right there. And if we read it, can you see it in the camera? I'll just move this out of the way. 0.05. So this capacitor is great. Let's take a look at it. So when I look at the end, I look where the wire goes in. Looks sealed tight to me. Sorry, it's a little out of focus there. And on this end, same thing. No cracks in the seam, and it looks good. Well, here's another one. This is another sealed tight, small capacity one here. It also looks pretty good. So what this is telling me is certainly taking out this may have affected the radio. Taking out this one, not so much. Okay, she's ready to go. Here we go, 25 volts leakage. It's another good one, 150, 250. Not quite open on the 250, but close. So the likelihood of this one causing trouble, not so high. Yeah, I think this is the one that was controlling the grid. I think. 0.01. So this looks a little roughed up on the end here, you know, but I'm sorry, again, it's out of focus here. That may have been me taking it out. Let's check it. When these things are a little leaky, just a little bit leaky, when you test them on a tester like this, they tend to read high. And it's probably just because the tester is counting on there being no leakage. 25 volts on the capacitor. 150. 250. Look at that. So these particular seal tight ones, they look good and they are good. That's what's happened here. Even this one, that looks a little bit roughed up. I don't think I have a really bad one handy to show you. But, so that's the story there. So these, you know, this capacitor is basically the same as this one, except this one has a plastic shell over top of this. That's kind of the difference. The plastic shell gives much more resistance to picking up moisture. Moisture is the killer. Moisture is the killer. So these ones have no plastic shell. They're just counting on wax. I understand it's beeswax. So this feels fairly dried up, wax-wise. Anyway, that's the story there. You never know. It seems I never know with capacitors, but generally they're better than people expect. People think change all the capacitors, put new tubes in. Boy, 90% of that effort would be of no benefit. So, okay, people, don't think that. Now, time to do the alignment here. What's up? I have a visitor. If you notice a cat, I don't know if you notice this about cats, but see how he's just standing in the doorway? He's not coming in? Cats are extremely sensitive to coming into somebody else's territory. They're very polite about it, believe it or not. Cats are polite animals. So, Peanut, come on in. Yeah, no, come on in. Come on. You can come in. You're welcome. Come on. Come on, that's it. Come on in. Yeah. So I pour Peanut here. Ooh, ah, big heavy Peanut. Peanut wants to go outside, but it's raining outside today. He can't go. Peanut, say hi to the folk. Yeah. So I can pick this guy up. I can't pick up my other cat. But he'll ride along in my arms here for a long, long time. This is quite a nice cat, this guy. Okay, Peanut, down you go. Go play with Shadow. His tail's up, he's happy. Let's see what they're going to do out there. Leave his butt alone, will you? Okay, we're not going to watch some kind of cat butt action out there. Okay, back to the radio, which it's okay that it sits here and runs for a while anyway, before I do this. Okay, so I think I got things set up here to start the alignment. What I've got is I've got this meter monitoring the sound coming out of the speaker. Why it's going up and down like that? I have no idea. We'll try to figure that out before we start. You can't do an alignment with a meter going up and down like that. But, so this is a decibel meter. This is a real laboratory quality instrument, even though it's a little old, but it reads in decibels. That's fine. So I think here on the lower scale, the red scale, is the decibel scale. The upper scale is a relative voltage scale, depending upon where you set this. There's a sign of where our problems are. Well, I don't know what to do about that. Son of a gun. Try another lead here. So these leads I'm plugging in are just connected to the voice coil on the speaker. It's just over this way. That's a little better. A little volume. There we are. So you see how sensitive that meter is? Small change in the volume, big change on the meter. That's exactly what I need to do this. Okie dokie. In the meantime, my frequency counter has gone wild. Okay. So we're going to go now to the first shortwave band. We're going to tune in the bottom of the band. Tune in the signal generator at the bottom of the band. Here we go. Okay. We're currently, what frequency are we on here? Just see if I can rotate this far enough. So we're down on this band here, this green one. In the police area, 1.8, 1.82. So we're around somewhere below 2. A little bit of volume. Okay, and now we're going to tune in the signal generator. Somewhere below 2. Come on, you can do it. You can do it. Looks like I got another piece of equipment to work on here. Come on, don't give me this hassle. Spray some cleaner in that thing, Jim. That fixed it. Ah, there we are. There it goes. Ah, this is still putting out a signal, so let me tune it in. I'm just going crazy here today. I saw 1.7. There it is. Well, that's indicating a fair bit of sensitivity already. Let's try that. So this is a fairly low signal. And it's coming through pretty clear. Not much volume. I think this is telling me when I try this on an antenna, it's really bogus. I mean, it's a fairly low shortwave frequency here. You really need a big, long antenna to really pump a signal into it. So what's this going to show us? So what I can do is, what quick and easy thing can I do here? This is gonna, I gotta make this work. Gotta make that work. Too many challenges in the day here. Anybody see what happened there? I have no idea why that got so loud suddenly. Well, there's a powerful signal maybe here. That's probably what it is. I don't know. Who knows? Let me plug this in again. Turn this down. Okay, now I can relocate the camera here. Wow, this has been a real struggle here this morning. Can't quite read that number. You'll have to trust me on it. Okay, let's move on. And now my frequency counter is working over here. Okay, turn up the volume a little bit. Okay, I think I'm actually doing something now. So you can watch this dial here. We don't have to watch that dial. Let me peek it up. Okay. So we're at 1700 basically coming out of the signal generator, and we're tuned to, let's see, there's 1.8, 1.62. Oh my gosh, how are you going to figure this out? They've kind of put this police band in there and then just put two long things on either side of it. Well, if that's 1.8 and that's 1.6, 1.7 would be roughly in the middle. That's roughly where it is. Tell you what, here's what we'll do. This is a smarter move, Jim. Be smart. Put it on 1.8. So that's 1.8. 1.7925 is what this says. let's go up to, say, 3. Quite a parallax error in these things. So that's right on 3. Let's see. Pretty quiet. Okay, I'm dialing it up to 3 now. 3.5, 6, 7, 8, 9. Pretty weak now. Quite a bit stronger on the lower end of the band. It's a bad sign. So the frequency is 3.050. I mean, there's no precision in this dial. That's really good. That's really good. Let's go up to, let's say, 5. We'll go up to 5 and check it there. Remember, this pointer was all bent out of shape. I mean, there's problems with this. Getting this to be exactly right. So 5. Now, hopefully, we're going to get to 5 here. Let's see. Okay, we're at 10 megahertz coming down. 8, 7, 6, 5, 9, 8, 7, 6, 5. Right there, 5.386. It's a very weak signal. That's a moderate signal now. .386. So 5.386 is way off here somewhere. So it's actually quite a ways out up here. Now there's 2 adjustments to be made for this. 2 alignment adjustments. One is a oscillator adjustment, and the other one, it will be a front end tracking tuning adjustment. I got to figure out which one is which. Okay, so now I got this far, I got to actually read some instructions. Okay, so here's the instructions here. Alignment of police band. Police band. Band con. What's that? I don't know. Rotate tuning nominal pointers at 4800 on the dial. Supply 4800 signal aerial and ground leads. Adjust police band oscillator trimmer C8. So that's the first one. While rocking the gain capacitor to and fro past the signal until the combination of adjustments gives the greatest reading on the output meter. So C8 and rocking. Okay, let's do that. Okay, first we gotta tune the radio to 48. 4800 is here. It's way up at this end. Now I'll make sure this is exactly right. On the money. Carefully setting it wrong. There we are, 48. 4.8. 4800. Now we'll adjust the signal generator to 38. Okay, so that's at 5.06. Nothing at 48. Remember, I did say it was out quite a ways at the top, so this is good. So we'll put it to where we hear it. Then we'll turn the signal, we'll move the signal towards where it's supposed to be, towards 4800, just a little bit. Okay, so I can still hear it. That way I know when I turn the adjustment that I'm going in the right direction. This is it now, C8. I didn't quite take the time to know C8. where C8 is. Let me just take a peek here on my own. C8, okay, C8 is on the deck of the radio. This thing's as stable as can be now. There, you can read that 5051. 48. This isn't quite on 48. Make it as exact as I can. Make this come back a little bit. There. You just hear it. C8 is this guy here. How am I going to get this visible? C8. Oh, come on, yeah. This is really a crazy day for me. Nothing's working. C8. Watch this. We're supposed to rock the tuning too. Well, I got to get it down to 48 first. Okay, that's higher. That's good. Right past. Now we'll move this one past. And we'll play hopscotch all the way down to 48. I call it hopscotch, but oh, don't do that. Not now. Stay there. 48. Yeah, 48. Volume down. Tune the radio. Tune the trimmer rather. Son of a gun. The screwdriver keeps slipping out. Try again. Here we go. Now the AVC is active in this radio. It's a pretty loud signal going into it. So as I tune it in, the AVC is reducing the volume. So you can see as I come in, the needle goes whoosh, and then immediately it comes back. That's the AVC pulling it back. There's also a little bit of weight in the needle. There's some damping issues with all these meters. The needle can be thrown a little further than it really should go. So in the midst of all that, you're trying to maximize it. It could be a little tricky. But I think I've got it here just about as good as I can get it. In fact, another way to check that is to tune the radio a little bit. Yeah, I mean, I'm not going to get any better than that. So that's 48 where 48 should be, but I was supposed to do this rocking thing. Let's try that. The rocking process, you know, I've never been comfortable with it. So first we gotta tune it up to max here. Tuning it. Okay, and I'm turning the screw a little bit. I don't know, am I gonna get this any higher? I hate having two hands on a chassis at the same time too. I don't like that. This is really tough to turn this capacitor. Make sure this is right on 48 again. I don't understand the rocking principle, especially when you're doing the oscillator. That's good enough. That's got to do it. I'm not going to get any better than that. So now the next part, I can't talk over that. The next part of the process involves, let's take a look. Shift test oscillator 1720, rotate tuning capacitor 1720, signal is reached. Oh, it doesn't say set the radio to 1720 and make it work there. Adjust police band oscillator tracking C11 or rocking gain capacitor to and fro. Okay, so C11 is right here on the back deck of the radio. 1720, away we go. Okay, 1720. $17.20 on there now. Tune this to 1720 or so. Hopefully we'll hear it. So 17. $17.20. Oh yeah, it's right in this area. It's so hard to figure out where that is. Oh, for crying out loud. Okay, so this is 1.8, 1.6. I don't know how to read this. 1.6. What have they done here? 6. Somewhere in the middle. You know what? It didn't matter. What am I doing? It didn't matter. Just said tune it in. Tune it in. So let's tune it in. I think the set's become more sensitive already. That's pretty good. Okay, so question is that about 1720? So if we say 1720 would be about exactly between 1.8 and 1.62. Or just about exactly. That would be there. Well, let's try that. Let's try it and see what happens. So if that is supposed to be 1720, what is it really? 1690. So we'll go past in the direction we want to go. And now, my hand's on the back of the radio. What's this one here? How are we doing here? Can anything go wrong? Where's my meter? Now the object is to get this to 1720. That's our first objective. So I should turn this to peak it up a bit. That'll be going in the right direction. Okay. Wow. Oh, smokes. Turn down the volume here. Okay. Wow. Oh, this just keeps getting louder. Okay, that's good. I'll go past. I will move this towards 1720. We're just about dead on already. 1720. Now we'll peak it. I get my hand right in front of the meter, don't I? Let's turn it up a bit. That's it. That's the whole process right there. Oh wow, that was quite a battle. Pretty straightforward now to move on to the other short wave band though. So why don't we do that? We'll just move right on to it. Let's start by reading. Wow. Start by reading here. Alignment of shortwave band. Turn wave change to shortwave band extreme left. Rotate tuning knob pointer till it's at 16. Supply 16. Shortwave trimmers 6 and 4. Shift oscillator C10. So there's 3. Recheck 16 alignment. Okay, so we're going to go to 16 megacycles and we're going to tune these two guys, C6 and C4. C6 is this one. That's the third one from the back. 1, 2, 3. Third one from the back, and then the short wave is this one towards the center. I think I can remember that. $16 megahertz to start. $16 megahertz, right? Actually, I had to double check that. Yeah. Okay. So we'll set this to 16 here. Band switch. Dial 16. Where's 16? 16 is. What's that? 16, hard to see. 10, 14, 16.5. There we go again. There's no 16 to stat it on. So, again, there's no reason for accuracy in this, like precision in this, because the dial is extremely imprecise on this. So if that's 16.5, and this is 14, so that makes that a 2 all the way down to there. So we've got half of a 1. It really looks like this long line here. We'll declare that to be 16. That is 16. By fiat, I have the power. Turn up. Don't hear a thing. Okay, so now we'll turn the signal generator up to 16 megahertz. 16, 17. We'll put a moderate signal in. Turn the volume up. It is up. Everybody listen. Didn't hear a thing. We'll go up another step. Nothing. I'll turn up the volume. It's quite low actually. Volume's up. What's happened? Okay. This is a blazingly powerful radio signal you would never get off an antenna. Okay, so another thing that's happening with this radio is the tuning is extremely fast. A little tiny, well, I'm tuning this guy right now, a little tiny adjustment there, all over the place. Let's compare with the actual tuning on the radio. Using the fine tuning control. See, that's pretty fast too. So there we've got the so we're just south of 16 here. It's actually quite fine. So the first adjustment is an oscillator adjustment. Well, why would I want to move it if I think it's correct already? So then the second adjustment is supposed to be done at another location on the dial. Yeah, let's just do what it says we should try. Everybody stable? Third from the bottom. Third from the bottom. Ah. Okay. I'm in. Here we go. Somehow I think this can only make it quieter the way I'm doing this. Where did it all go? How come it's jumping all over the place? See, just pushing on the, just physically pushing on the screwdriver changes the capacitor enough to cause that. So, turning. It's not good. It's showing almost no. Oh no, there's an effect there. Wow, this is bad stuff. For those of you who are saying, you're using a metal screwdriver, that's why it's doing that. Let's find out. I don't think that's the case. I think it's rigid enough. Okay. See, you get the same effect because I really can't. I can't get anywhere here. Even just beginning to put pressure on the screw causes the meter to jump around. So it looks. I've got a huge signal coming into this thing. Turn it back. Yeah, wow, this thing's really insensitive. Well, let's just carry on with the instructions here. So we'll assume it's good at 16. Oh, two of them. C6 and C4. Oh, at 16 I do the other one. Ooh, almost made a boo-boo there. Okay, so this is the one that may bring this radio to life. And go back to the metal screwdriver. Tuned in. See what happens when I do this. The same jumpiness. So I'm going to go up there for a while. Can't get much more than that. Wow, it's still extremely insensitive because I'm pumping a huge signal into this radio. Let's carry on. Let's carry on because maybe, as I was about to say, maybe the next one we'll do it. 56. Put in a 56 to just C10 and C10. Made a mistake here. I made a mistake. Just 1 second here. C4 and C6. What C6 and C4. C6. I did the wrong one. So under this arrangement, there's another one on the front deck here I should be doing. Where did the signal go? Simply tuning. That's all that was. Shaking the radio is making it tune back and forth. So bring that up. The weird behavior of that meter is mostly AVC, I think. So next thing I ought to do is C4, second from the top. Hope this one brings the radio back to life. Oh! What was that horrible sound? Uh-oh. Uh-oh. What would that be? It's working good, working better. What was that sound? It feels like the control is sticky now. Oh my gosh. What should I do? Should I try more? Let's try more. The thing is so insensitive it's almost unusable. In fact, at this point, let's do this. Turn that down. Turn up the volume. Where to go? Wow. This is not too good. I gotta be able to hear it. Okay, so I've turned down the output using a vernier on there. Here we go. Okay, it's turning okay. What a big change that was. There's some strange sounds coming out of here. I don't think they're being picked up by the mic, even though the mic is just that far away. It's right here. It's just like a foot away, so you're really listening to my screwdriver in that. I think we're at the peak. Wrong way. Okay, so I don't know what that click was. Got the tiniest improvement here. Okay, let's go back to 16 or what's happening? Okay, we're going to try this whole thing again, starting with this one first. Came up just as I more or less loosened that capacitor right off. It's telling me this isn't really at 16. It says on the instructions, set it to the 16 megahertz marking. Again, if this is 14 and that's 16 and a half, that would be 15 in the middle. The best I can do is say 16 is this long line here. That's fine. Okay, so we're doing third one. Wow, practically the screw's going to fall out of that capacitor. It's so loose, but it goes up. Let me do that. Tighten it down a bit. Tune the radio for maximum here. And I'll adjust the other one, which also went for quite a ride. No, it's peaking where it's peaking. Okay, well, we'll go, the instructions say go to the other end of the band now and kind of do the same thing. Go to 5600, C10 while rocking. So 5600. Boy, I just don't think this is going to come back to life here. So 56 is that line right there. Right there. 55, 56, 57. 56 on a bent pointer. Okay, 56. Wha! Okay, so you saw what happened there. I just tuned past it, and it's because this is up so high. So it's pretty sensitive down below now. Let's try there. Try there. So it's supposed to be 56, it's 56.25. You know, that's the difference between about there and there. So I think I'd be pretty happy with that. Let me max it. jumped downwards. What's happening? What happened? It just kind of disappeared. Hey man, where'd you go? Right in the middle of that. I didn't really do anything. What happened? It's departed. Oh. How'd it get way up there? It's right on the money. Okay, I have no idea what occurred there. Something did. I don't know what. Let's do this. Let's do that. That's the best. Turn down the input signal. Okay, back we go. A little signal there. That appears to be it. Recheck 16 megacycle alignment. It's probably to check to make sure it still says 16. I'm not going to worry about that. I don't think there's any more I can get out of this radio. So that's actually pretty sensitive now on 56. Let's go up to the other end of the band, just check the sensitivity, because this is actually good. This is actually good enough for a radio like this. Come on, little. You can do it. Don't quit the string now. I'll give a little hand. Around. So I think that's 16 there. Don't touch that. Don't touch. Okay, 16 here now. No sign of it. Next one up. No sign. One up. Tubes sensitive? Coils? Who knows? Well, ooh, I should have done that. What's down there? The band switch? I've never really checked this band switch very carefully. Look at that. Just moving the band switch. Just forcing it. Okay. I'm boobed up here big time. I should have really cleaned this whole switch. That's where the sensitivity is coming from. So I think let's give it let's give it this pretty potent cleaner here. And I don't want to do this with the radio on because I'd set a radio like this on fire with this stuff. I sprayed it on the switch, cleaned her all up, waited 10-15 seconds, turned the set on. I think maybe the set was even on, changed the control, and flame came out and started, just sat back here. Not this radio, another radio. I want to repeat that. It's on video. So this is powerful cleaner. This is really stuff you use in your automobile. But I'm going to use it on the switch here. Sets off. There we go. You can almost feel the grease and lubrication disappearing in it. Okay, let's switch it on. You know, if we get a little bit of a fire out of it, that's kind of a cheap thrill for the morning, isn't it? Now this will throw the alignment off the whole radio. If this thing is really introducing effects, it's probably affected all the bands. Okay, it's warmed up. Don't hear a thing. Should be warmed up. Plus this, I forgot about this battery down here being not working. Okay, I think what I'll do, I'll leave this guy tuned to roughly 16. Now you know what? I'm going to hunt for it. There we go. There it is, right there. Short distance away. Try the wiggles, the switch test. Comes back roughly the same spot. Still something in there. Now I was touching something down this way. Seemed to me. Oh, you see that? What's going on here? Just touching a wire with a piece of wood can cause it to detune. There's all kinds of wires kind of in various contact in here, like not contact but proximity. I'm just moving one of them there. Let me do it again. Just a little bit. So if that's so sensitive to these wires, if there's any movement in them, ooh, what was that? Give you a close-up look at what I'm doing here. It's just a little hard to believe that it's having any effect on anything. I seem to be really good at finding weird stuff. Okay, now this wire here. See that? What is that? This is something weird here. This is not like, you don't clamp a wire down like that. And if I touch it, Just touching it. Is there something? Is this wire shorted out under here? What is this? Is there anything else in the radio like that? Well, I've never seen something like this. It looks to me, I don't know what to make of that. That's a capacitor. Look at this. You can see I'm moving the wire a touch. Touching other areas on the wire. They move that wire in the slightest, and it looks like this spot gets well. The only thing I can conclude is that that is a weird, super small capacitor. Bizarre. And the wire insulation maybe isn't what it was. Maybe it's even almost shorting or partially shorting under there. What am I supposed to do about that? I gotta find out what that is. Oh my gosh. Let's see. So it's going up into the coil here. No, it's coming around. It's tying to the switch here. Up here. So this is the wire here, but you can hardly see it. This is it here. You can see it clearly, looping around, coming up to the switch. The other way, the same wire comes to this point here. That point is a point up onto the capacitor up above. Now what happens if I move this big capacitor around a little bit? So I'm holding the frame of the capacitor and I'm moving it around just a little bit. There's a strange sound in this radio. There's like a click. That sound. There. Okay. Okay. Well, this was a radio with a wildly loose capacitor, and I tightened it down by doing this. So I mean, if the capacitor can physically move, I wouldn't be surprised if that would have tuning effects on the radio. That's one of the hold down nuts. But we're talking about tiny changes in this radio to make it tune differently, and that's probably all we're hearing. It's just see, there could potentially be another hold down screw here, but there isn't. They left that out and they've used it to bring a ground strap in. I missed something that's even more sensitive. No, it's all about this wire. And rocking the capacitor rocks this wire because it's soldered right down in here. It all comes down to this right here. I mean, is that better? So just changing the tuning doesn't mean anything. Let's see, the way to prove that would be to move the wire and then try to retune the radio. Let's see, we'll move it. Without moving the wire. Yeah. So I think all that's happening here is the local oscillator is drifting around a little wee bit. We're at the high end of a shortwave band that's pretty not sure the right word, dense. It doesn't take much of a turn on the tuning to. So I don't think, you know, I think that amounts to nothing. Just another curiosity. It explains this. It would mean every time you go to tune this radio, you flex the capacitor slightly, the big tuning capacitor, and move that wire. So the fine tuning is nice and smooth because there's no force on the capacitor. But I use this one. I didn't really move it anywhere. I didn't turn this really anywhere. Just kind of flexed it. And there may be other okay, so yeah, look at that. This just isn't the best radio for precision tuning on the high frequencies. But and now, where do we get to for signal strength? It's still lousy. Yeah, because the volume is up full to do all that. So a problem with high frequencies in a old radio like this can be because of a couple of factors. It could be capacitors still in here. Ones I generally regard as reliable, but maybe not. Another possibility, a more likely possibility, is one of the tubes in the front end can't handle the high frequencies anymore. It just can't do it. But I think that's where I gotta stop now because I'm losing my mind here. Okay, so thanks for watching. I think the next stage for this radio is for me to flip it down, put an antenna on it, play with it, see how well it works. I gotta wait till the evening to do that when the shortwave is a little more active than it is now. Okay, let's see how much fun we can have with it. I'll probably do a separate video for that. Thanks so much for watching this cockeyed one. I don't know how much of this I'm going to post because there was a lot of screwing around. But yeah. See ya.